Aisha here, water scientist with the Severn Sound Environmental Association, and today we're going to talk about salt in the Severn Sound watershed. So what do we mean when we say salt? In this context, salt really refers to the road de-icing salt, and the vast majority of salt used is sodium chloride. There are other types of chloride-based compounds that are used, but the vast majority is the sodium chloride. In water, the salt dissolves and dissociates into its two component ions, the sodium and the chloride. Salt is highly soluble and easily moves with water to contaminate lakes, rivers, and groundwater. Sources of salt include winter-maintained highways, roads, parking lots, driveways, and sidewalks, really any hard surface that we want to keep clear of snow or ice. But also we have to think about snow disposal sites that might be used by municipalities or commercial properties, and also salt storage sites. So what are some of the issues with salt? We can sort of break this down into aquatic health, human health, and infrastructure costs. In terms of aquatic health, it's chloride that's more the issue. So the guideline in Canada is 120 milligrams per liter. So this is for a longer term exposure. However, newer research has shown that the impacts on some aquatic animals like zooplankton might actually be lower than that. So to give some context, in Southern Ontario, the background for most lakes would be 10 to 30 milligrams per liter, and this will help when we get into some results a bit later on. Another thing to consider is that chloride concentrations may act as a cumulative stressor. So the impact from chloride may actually directly or indirectly be exacerbated by impacts from other stressors, for example, climate change or invasive species. In terms of human health, it's the sodium we want to look at. So at concentrations above 20 milligrams per liter, this can actually become problematic for individuals who might be on a sodium-restricted diet, who have hypertension or those types of issues. So in any water that's used for human consumption, people have to be notified if those concentrations are higher. In terms of infrastructure, you can think about the damage it does to your vehicle, but also corrosion of concrete structures, so buildings, bridges, sidewalks, and that sort of thing. So to measure the impacts of sodium and chloride, the SSEA conducts routine sampling in lakes, inland lakes, rivers, and groundwater across the Severn Sound watershed. So we sampled a total of 119 sites across various years. So our lakes are sampled every 2 weeks during the ice-free season and sort of rotates depending on the water body we're looking at. So Severn Sound is sampled annually and most inland lakes are rotated every 5 years. Our rivers are sampled as part of the Provincial Water Quality Monitoring Network. So we have 14 sites sampled approximately 8 times per year, and this includes through the winter, which gives us a really great picture of what's happening with salt concentrations. We also sample groundwater as part of the Provincial Groundwater Monitoring Network. So these wells are monitored once per year, and municipal wells in the area are also sampled annually by municipal staff. So there are different ways to look at the data that we collect across the watershed. If you look at the graph here as an example, so this is chloride at the Port Severn Dam. We can look at the most recent concentration, which in this example, 33.5 milligrams per liter in 2019. So we can compare that value to relevant guidelines and get a snapshot of what conditions are like. Or we can also look at the trend, so that's the red line shown here, and this really shows the rate of change, so in this example 0.49 milligrams per liter per year. So we can use this trend to determine whether things are increasing or decreasing or improving or declining, and can also estimate future concentrations. So for this analysis, in terms of recent concentrations, we use the median concentration value, so the middle value, that was calculated for lakes and river sites to give us an annual value. This minimizes the influence of outliers. On the summary map that you'll see, all recent values shown are from 2010 or later. So we don't always have a really recent concentration, but everything will be at least 2010. In terms of rate of change or the trends, sites that were included in this analysis had to have at least 8 years worth of data to be considered in the trend analysis. And we used a type of statistical test called a Menn-Kendall trend test. And again, this minimizes the influence of outliers. So we'll get into results here and start with sodium trends and recent concentration values. So the map you're looking at here, each symbol here shows a site where we have sodium data. You'll notice the red watershed boundary lines as well. And so the shape of the different symbols indicates whether it's a tributary or river site. The triangles indicate groundwater sites, and the squares are the lake sites. So you can see on the legend down there that the size of the symbol will correspond with the rate of change. So the very large symbols are increasing at a faster rate than the smaller symbols. The colors you'll notice, so the scale ranges from 3 milligrams per liter, which is the kind of darker green color, up to as high as 70 milligrams per liter, which was only detected at a couple of sites that were up in that range. So getting towards the warm colors, you're getting into higher concentrations. So with the analysis, we discovered a few problem areas in the watershed. So definitely in the Silver Creek area, which is the circle that's over towards Lake Couchiching. The Severn River had higher concentrations as well. Lake Couchiching itself, Gloucester Pool, Orr Lake, Baxter Lake, Midland Little Lake, and there were 3 wells in Oromodonte that had higher concentrations that are above 20 milligrams per liter. So again, this is more of a human health concern, so if folks are using water from those areas as a drinking water source, and if there are any health considerations, that might be a conversation that they might want to have with their health practitioner. So looking at chloride concentrations now, so we have a similar map here where the shapes indicate the type of water body, the size of the symbols indicate the rate of change of chloride concentrations, so bigger symbols, greater rate of change, and the colors indicating concentrations. So the red side of the spectrum indicate higher concentrations. So we can see here similar to sodium, and the two definitely go hand in hand. Silver Creek, we actually have concentrations above 120 milligrams per liter, so the Canadian guideline. Severn River concentrations aren't quite as high, but definitely on the higher side of the spectrum. Lake Couchiching, high concentrations as well, and Orr Lake, Baxter Lake, and Midland Little Lake. So looking at these findings, we see that 23% of all sites are above 20 milligrams per liter for sodium. There are 2 tributary sites that are above 120 milligrams per liter for chloride. So these are Silver Creek, as we pointed out, and also a small tributary up in Honey Harbor area in Church Bay. 16% of all the lake sites were above 40 milligrams per liter, which was suggested as a possible more sensitive threshold for creatures like zooplankton. Sodium and chloride concentrations have risen at 62% of the sites that have more than 8 years of data. And we have 5 sites that are rising at more than 0.5 milligrams per liter of chloride every year. So looking at the 3 different types of sites, just making some general observations, we notice that inland lakes have higher concentrations than the open waters of Severn Sound, which makes sense if you think about how Severn Sound is circulated more frequently. The east side of Severn Sound has higher concentrations than the west side, and so this really is attributed to the influence of the Severn River coming into the east side. Many surface water drinking water sources are above the 20 milligrams per liter threshold for sodium. So this includes Little Lake, Orr Lake, Severn Sound, and Lake Couchiching. And we have several lakes that are above the 40 milligrams per liter for chloride. In terms of rivers, as I mentioned, Silver Creek has high concentrations, and the Severn River is also relatively high for both sodium and chloride. In terms of groundwater, we have several wells in Oromodonte that have concentrations for sodium above the 20 milligram per liter threshold. So what can we do to try and minimize the amount of salt used and reduce the concentrations of sodium and chloride in the watershed? So from various levels, from residents to commercial property owners and property maintenance companies, up to municipal, county, and provincial levels of government, there are things that can be done to track salt usage and minimize wherever possible. It's important to quantify what's being used and see where that can be reduced. There are training programs available through the Smart About Salt Council, which are beneficial for commercial property owners and maintenance companies, as well as municipal government staff. It's important to implement these strategies to reduce usage wherever possible and explore solutions when designing our communities and our parking lots to reduce that usage as well. It's important to note that even as reduction programs are put into place, it will take time to see changes in the landscape, as chloride in particular sort of builds up in systems and takes time to flush through. So it will take time to actually notice reductions in surface waters. So I'm going to talk a little bit about a project that was done this past summer in the LaFontaine Creek subwatershed in the township of Tiny. This was done by a third-year Georgian College student, Nicole Romer. And we looked at the LaFontaine Creek subwatershed in particular, basically just based on available data that was provided to Nicole. And so we needed data that was complete across an entire subwatershed and not split into areas that were outside of the SSEA watershed. So using GIS analysis techniques, she used road length and the total amount of salt and dust suppressant that was applied by both the township and the county to determine the total usage across the LaFontaine Creek subwatershed. So as you can see from the table here, she used roadway lane distance as well as the average application rate to calculate the total material that was applied. And then from there, we were able to calculate the mass of chloride and sodium in particular that was applied both on a watershed total basis and then also per unit area of the subwatershed. Now, keeping in mind that township staff informed us that salt usage was not uniform across roadways, that they would target, some of the trouble spots, bus routes, hills, and that sort of thing. So this generalization of usage across the unit area of the subwatershed is sort of an estimation there. Nicole was also able to look at trends in total usage, both from the township and the county, and found that this has been increasing for both dust suppressant and salt usage since 2017 when records were available to us. Unfortunately, at the municipal scale, spatially derived data was not available in terms of where salt spreading occurs, and so as we mentioned, particular trouble spots that are targeted, we weren't able to determine where those spots exactly were. So this type of information would be useful for further studies to identify where high usage occurs and relate that to where some of the sensitive areas are. So places like groundwater recharge, wetlands, and also streams. So this project is a good example of what we can do when good record keeping and material tracking is done. And so this is something that if the data is available, we can do this for other subwatersheds across Severn Sound and also on a municipal basis as well. So I've provided some resources here, in particular the Smart About Salt Council, as I mentioned, which has salt reduction tips and also information about their training courses offered. The Lake Simcoe Region Conservation Authority has some great information about salt usage as well. And it's worthwhile to check out, particularly for municipal public works staff, the Code of Practice that has been published by Environment and Climate Change Canada. So to summarize, sodium and chloride concentrations have risen at 62% of monitoring sites across the Severn Sound watershed. We have several surface and groundwater-derived drinking water sources that are above the 20 milligrams per liter threshold for sodium. 2 tributary sites are above 120 milligrams per liter for chloride, and several lakes and rivers are above 40 milligrams per liter of chloride. So mitigating these concentrations and starting to see reductions will require tracking and quantifying major salt sources. So these are mostly from municipal operations as well as commercial properties. It's important to encourage and or require Smart About Salt certification programs, particularly for commercial property owners and salt application contractors. Reviewing and adapting relevant parts of the Lake Simcoe salt reduction plans for Severn Sound will help us get a plan in place to help start reducing some of these concentrations. We need to enhance public education about some of the negative impacts of road salt and promote benefits of using less salt, which include improved safety. We need to explore solutions that have been applied in other places to reduce salt usage. And it's also important to revisit some of the guidelines, particularly for chloride, to make sure that sensitive aquatic life are adequately protected. Thank you for your attention and your interest in this subject. As always, you can get in touch with us if you have questions. And to learn more about the Severn Sound Environmental Association, you can get in touch on our various social media platforms and also on our website.